Hello, team. Vinit joined the call.
Good evening, sir. We would be just starting in few minutes.
Sure, sure.
Good evening, everyone. It is my privilege to extend a warm welcome to our esteemed guest, Mr. Vinit, for today's guest lecture. Mr. Vinit is an accomplished AI product leader with over 18 years of experience in building and scaling intelligent, cloud native platforms. His expertise spans across cutting edge domains such as generative AI, LLMs, RAG, and genetic AI systems. He has successfully led multiple AI driven transformations, delivering significant business impact, including cost optimization, revenue growth, and accelerated product innovation. Currently serving as a product manager at Netcracker, he plays a key role in driving AI first product strategies and developing advanced cloud based solutions for global enterprises. We are honored to have him with us today to share his valuable insights, experiences, and vision on the evolving landscape of AI and product innovation. On behalf of everyone present here, I warmly welcome you, sir. Looking forward to an insightful session. Thank you.
Thank you. Thank you for the introduction. Let's get started. Let me share my screen. Mhm. Let me know if it is visible to everyone. Mm. Are the slides visible?
Yes, sir, it's visible.
All right. So let's get started. So good evening, everyone, and thanks to you for joining the session. I am Vinit Metange, and over the next hour, we will be going deep into the something I'm genuinely passionate about, building AI products that don't just demo well, but actually shape, scale, and generate the real business values. So let's get started. So I'll skip on the introduction part as we have already gone through the introduction. So we'll move into the next, but it's my quick LinkedIn if anyone wants to connect here. So we'll move to the directly into this presentation. All right. So let me start with the hard truth. It's the 73% of the product managers now use AI weekly. 71% of enterprises are actively piloting the AI. The enthusiasm is everywhere. You keep on reading the news, you LinkedIn everywhere, you see the AIs. But here is the paradox: the 70 to 85% of AI project fails. Only about 5 to 15% reach to the production scale. 60% never even leave the pilot stage. And why? MIT, Gartner, NTT, all research data all confirms this. Today, we are going to fix this. We will walk through the end-to-end execution framework that separates from 15% that succeed from the 85% that don't. Okay, so three core reasons why most of the products, most of the AI initiatives don't reach to the production scale or they fail into the productions. Key three reasons: they don't have the evaluation strategy in place, they don't have the cost control implemented, and most important, no trust or the adoption plans. Let me start with my own story. A few years ago, when we started implementing the customer support agent, we had given the demo. In demo, it was looking very beautiful because we had limited API calls to show, and we had a perfect response coming from those APIs. Latency was well under the 200 milliseconds. Everyone during the demo was impressed with the demo, and we got the budget and go ahead also. 3 months down the line into productions, we had more than 10,000 concurrent users during the peak hours. Latency spiked well above 2 seconds because we were not using the caching. Hallucination rate was acceptable during the demos, it was well under 1%, but it became catastrophic at the scale. One in every 20 responses had a hallucination observed. and most importantly our AWS bill, it was bleeding because we were not thinking about the cost well before. We had thought about the cost, but we had not considered all the elements that would contribute to the cost. And many team fails here. They don't look at the holistic view of all the elements that could contribute to the cost. So the gap isn't because the demos are fake. The gap exists because we are not testing the same thing in the production. In demo, you have control on everything, right? You control the input, you have the handpick examples, you measure the latency in a single request. But in productions, input varies. Right? There are users who can never supply the input the way you might have thought. Input varies, the environment varies, and the behavior varies. That's where you see the difference, and that's where you start to seeing the variation from what we had you had expected during the demos. So what we are going to do today, here is our roadmap. There are 6 interconnected sections. We will start with the fundamental mindset shift. Why AI products aren't like the traditional software. Then we'll go from idea to architecture. How to validate before you even start building. Section 3 will cover how AI actually built differently. The dev process is fundamentally reimagined. Section 4 is non negotiable. It is about evals, security, and the ethics. Then section 5 will address what really kills the AI at production and at scale, which is nothing but our cost and observability. And finally, we will look at agentic AI and the future. Each section will build on the previous one. So by the end of the presentation, you will have the complete mental model for building the AI products. Okay, so let me begin with the questions like, do we think that building AI product is different than the traditional product? What makes them different than how we are building the products today? Anyone of you would like to share your thoughts on this?
For multiple stages, we take use of the models, AI models, starting from the planning of any product to implementation or taking or searching data from the models. Right now it is a AI DLC kind of product
Mm-hmm.
we are, a process we are following,
Yeah. Okay.
or we are in the way of following that one.
Mm-hmm. Fair enough. Any other thoughts? All right. So let's look at what makes the traditional product different from the AI. The most important realization, um, if you are approaching the AI products with the traditional approach, then you will fail definitely. And here is why. The fundamental difference isn't the technology, it's the epistemology. The traditional software you see always has a deterministic output, right? You give the same input, your response will can vary. Your same input will result into the same output every time. Every time your response will always have the uh, definite format. But in the AI products, have the probabilistic output. The response can vary. In traditional software, the logic is fixed, right? You have the rule based coding, so you have certain fixed set of rules, and based on that only system behaves. But in the AI product, the behavior emerges from the data and the user behavior. As in when user behavior changes, your product response also changes. So you cannot have the deterministic input on output. So you have to deal with the behavior rather than the, you can say, the same output. Now you don't test with the unit test. You have a certain part of unit test definitely, but you, rather than unit test, you will have to have the behavioral evals. configurations and human feedbacks and observing the behaviors. You don't deploy once and then monitor errors like in the traditional product you deploy and then you monitor for the reliability. But in the AI products you deploy, you continuously observe it, and then continuously you have to adopt based on the observation, then retrain it, and this loop keeps on repeating itself all the time. The development process shifts from the way we used to develop earlier, like you have a requirement, then you convert that into a build and then shift to the shift. But into the AI products it has become fast paced. You experiment, you do a lot of experiments, you have to continuously learn and continuously iterate. It's a very continuous process and faster process. You can't wait for 3 months to have one cycle completed. You have to keep on doing the experiment, keep on doing the evaluations on the time, and keep on adapting to the behaviors. So it's a very fast paced environment in terms of development also. And the most critical ones, your cost doesn't scale with the compute like in traditional sense. It scales with the tokens you used, the inference cost, the amount API calls you make. Everything cost make money. And at scale this can kill your product also if you don't have the proper control. So I have a quote I wanted to you to remember. So in AI you don't debug the code, you debug the behavior. This mind shaped is the foundation of everything that is required for the building AI products. Now this is the life cycle of how the AI product would go through from the idea to uh, the working product. So stage one is the discovery. This is where we identify the real user problem, validate the business opportunity, and then define where AI can add a meaningful value instead of just building something with AI on its own sake. Prototyping, this stage, the goal of this stage is a speed, right? You want to quickly see the feasibility of the idea that you wanted to implement, quickly see, try to use some initial LLM prompt designs and generate the POC builds, test the use case, validate the feasibility, and learn quickly whether the model, workflow, and user experience are promising. Then we move to the evaluate stage. You have to build the eval framework, do the human review, run the benchmarks. This is where we measure the output quality, reliability of your product, safety, and whether the system actually meets the bar for the intended use case. And once you have that, you have to then harden this product. Hardening includes adding the security gates, defining the guardrails to make sure that your model works within the guidelines, within the limitations of the products, and of course the modeling of the cost that you have to harden to have the control. Then deploy stage where we include a lot of ML flows, CI/CD pipelines, version controlling, and then you deploy. At this point the product is released into the real workflows where actual user behavior and the production uh, traffic start teaching us what works and what doesn't work. But then most important stage is the observe and adjust. So this is the continuous stage. So once you deploy, your job is not done. So you have to observe and adapt. You have to monitor for the drift, monitor for the degradations into any of the metrics. You have to retrain, you have to redefine the prompts, and then you have to redeploy. Again, go through the all stages. So the flow cycle continues and it's a continuous journey. Okay, so let's talk about the journey from the napkin sketch to the system design. The number one mistake I see, and many teams do. That AI product development is starting with the model instead of the problem. Many people I heard saying, let's use ChatGPT 4, or let's build with Claude, or let's implement something with AI. But before they have even defined what problem they are solving. Is the problem relevant? Is it aligned with the business objective? This kind of study has not done, but we are already starting with the using of model. The right approach of uh, implementing any AI use case. First, define the business problem first. Translate that into the meaningful ML objective, and then select the simplest model that can solve it reliably. Notice here that in I use the simplest word. In today's world, we have very um, newer models coming very fast, and there are lot of new models, but each of those has a cost involving. So it doesn't matter that you have to use the latest model. What matters is what solves your use case reliably. So even if a fine-tuned smaller model can solve your problem with 95% accuracy at one tenth cost of the higher models. So always start with the what problem we are solving and not what model we should be using. Okay, so let now you have use case. So before starting any implementation, this is the framework you should use to run your idea to a four question validation framework. Question 1: does AI adds unique value? Can this problem be solved better than with the rules or the traditional code? If your answer is yes, you don't need to use AI. You are just adding additional complexity if you use AI for such use cases. Question 2: do we have the quality data? Not just do we have the lot of data. Quality matters more than the quantity. You know, the 100 well labeled examples can beat the 1,000 noisy ones. And the question 3: can you measure success? If you can't define what's good looks like with the specific KPI, you can't build an eval strategy and you can't improve the product. Question 4: will user trust it? Explainability and the safety are the critical aspects of the product. If your AI product makes a recommendation, can the user understand why, how it arrived at the particular recommendation? Can you answer when user questions the output? So I'll share the pro tip here. If you can't answer yes to at least three of these four questions, you are not your use case is not ready to go for implementation. You have to go back to drawing board and again revalidate the use case. Now let me walk you through the four architectural layer of any AI products. This slide shows AI product stack from user facing inference down to the compute. The inference is what user touches, right? Everything that user sees, your front end application, APIs, your servings, your real time predictions. Then comes to model provider intelligence layer, where we do most of the training, fine tuning, retrieval, vector search, context building, and then the data layer, which is the quality foundation, the ingestion of data, pre-processing of your raw data, and feature pipelines to make the data reliable for use. And then the foundation layer, of course, is the hardware and the infrastructure layer, where you have GPUs, TPUs, storage, cloud runtime. This is where the 80% of the quality comes from, and the scale is basically supported. So most teams spend 90% of their time on the model layer and neglect the data and inference layer. The real lesson here is that AI product succeeds when the full stack is designed well: data, model, serving, and infrastructures, not when the team only try to optimize the model in isolation. So every layer is important for a product to work in the production. So how does AI team build differently um, than the normal way of working? So here are the 5 fundamental shift in how AI team builds. The biggest shift is that the AI products are not built only through planning and engineering execution. They are shaped by constant experimentations, evaluations, and continuous adaptations. Second, the prompt becomes the product input. Earlier, we had a product space, PRDs, and all. In AI system, behavior is shaped by not just by the code, but by the prompts, by the context windows, by your retrieval strategies, and your workflow designs. Third, the development becomes e- eval driven, right? The traditional QA is still necessary, but is not enough. AI products never need evals. AI products always need evals, benchmark data sets, and human reviews to judge whether the behavior is actually useful or safe. Fourth is the observability changes. We are no longer just monitoring the uptime or the errors. We are also tracking model behaviors, token usage, failure modes, cost efficiency, latency. So there are a lot of now elements involved in the AI product that we need to continuously observe to avoid any degradations in silence. The fifth is the iteration become continuous. AI products are rarely finished at launch, right? Team keeps tuning prompts, refining retrieval, changing models, and improving outputs over time. The key takeaway is that the AI deployment development is less about shifting a fixed logics and more about managing the behavioral through an ongoing loop of experimentation, evaluation, and the iteration. Okay, so we started with the question like why do products work into demos but does not work into production. So this is the most critical part of having a product working into the production and at scale. If I had to pick a single most important concept, it would be the evaluations. Here is the golden rule of AI products. You can't evaluate, then you cannot ship it. So this is the 3 tier evaluation framework that you should be using. Tier 1 has the automated evals. So here you define the golden set benchmarking, basically the list of uh, use cases which are most critical for your products to consider as successful. You define the golden use cases of that, and then you use the higher better model as a judge to score the behavior of your model that you are using into the products. So every output you score with the help of LLM, and it tells you whether the output is accurate, how is the performance of the output. Then you do have task specific unit test to very smaller tasks that you can do using unit test, and then you define the regression suits. um, this catches the almost 60% of the issues automatically. For example, the metrics are retrieval relevance, answer correctness, tool call success, citation faithfulness, safety, and policy compliance. The tier 2 is more about a human evaluation. This is also very important. Not only automation can catch everything, so human evaluation in AI products are very important. So you have the expert reviewer panel. You define the red teams that tries to destruct or disrupt your product, try to give all the wrong input, edge cases, everything to break your products. Ground truth labeling they do. So this catches the nuance issues that automatic evals might fail. And then the final will be the online evaluations, which gives the production signal once you launch your product. So it's more about the user satisfaction signals, thumbs up, thumbs downs logic, task completion rate, and drift or any degradations alerts. This is your early warning system in production latency. Cost per task, tool failure rates, execution rates, repeated usage and retentions. So build your data set before you build the products, because it forces the clarity of what a good looks like for your products. So what success means for your product, and you can define the key metrics that will be used to measure whether you are on the right track or not. So evaluation framework is the most important. Once you have the eval framework built in, that will immediately give you the ROI. It will tell you whether your product is working as expected or not. So this is the one aspect that every product should be implementing. Now, the next, the most important is security and ethics. So this is also core um, critical aspects of the NEI products. So we know, right, on the security side, there are a couple of imperatives. Prompt injection prevention, right? So we have to prevent our system from the adversarial inputs that can manipulate your model's behavior. Then most important is data leakage on the PII project protections. So your model should not absolutely never expose any sensitive data or any training data or any customer data in terms of the model output. So you have to also do the input output sanitizations, validate everything that goes in and everything that comes out, add the access control and rate limiting to prevent the cost attacks or prevent the abuse. Then you have to have the model versioning and rollbacks. So you should know every prompt has to be versioned, and everything should be able to roll back to a good known state. Then you have a supply chain security. Know the provenance of your model and the data. On the ethics side, transparency is key aspects. User must know they are interacting with the AI. They should know that the system, they whatever the output or the response they are getting, this is generated by AI. And also it explainability. It should be able to explain why it arrived at that particular decision. Then bias auditing. Regular fairness checks you have to add across demographics. Human AI oversight is important. High stake decisions, if you have in anything in your product, has to be go via human approvals. You cannot let AI to take decision on the very critical and the high stake um, aspects. So some of the example might be like refund of customers. If AI can refund something which is beyond the um, approved range, they should not take those decisions by themselves. It should be routed to the human for approval. Accountability. So when you build the AI product, it is very important that anything that AI generates, any output that AI generates, any error that AI generates is the responsibility we have to own. We cannot say that model generated something wrong. No, because we are using any model, any AI tools, so responsibility lies with us. Then consent and privacy. Data, any data that we use must respect the user consent. If user gives consent for certain specific data, we have to only use that and never breach that. And the harm prevention, of course, strict guardrails for harmful outputs. We have to make sure that every output stays within the limits. Remember that the most dangerous AI is one that works perfectly but for the wrong reasons. Okay, so coming to the another most important aspect is the cost and the observability. Most of the products get scaled with the cost. Everything in AI products, everything that you do has a cost involved, and it can build up very fastly without even notice. So we have to have a strict control on the cost and the clear visibility of every aspect that leads to a cost. So this is the where all the cost goes. You have multiple layers that can um, contribute to the cost. So let me break down where the money goes. So you see the token cost account for almost 40% of your products. And this could be what user writes as an input. And then within the system, what we do from the context, call the multiple tools to form the right context, and we do a multiple steps LLM calls in between before arriving at the final output. And we do some of the retrievals, RAG, vector searches, and then finally what outputs get generated. So everything of this has a cost involved, and that costs almost 40% of the product overall cost. So this is the biggest expense at scale. Then you have inference infrastructure is 25% cost, like your GPUs and CPU cost, latency as SLAs, and auto scalings. And then embedding and storage cost approximately, I think, the 15%, you can say. Your vector databases, then for RAG you do the different chunking strategies, you implement various retrieval pipelines. And then 12% could contribute if you are making the LLMs more domain specific, to do a domain adaptations and the periodic retraining of that domain data. That would cost 12%. And then observability and eval cost least in the overall cost, but the most effective and most important aspects um, for building AI products. So here you should spend most of the cost, because this will give you the clarity on the cost that is being used in the top layers, and this can give you the complete visibility of that. So this is 8%, but most useful cost, I would say, to spend on a product. There are certain strategies that we can use to control the cost. For example, we can have a prompt caching implemented. Model routing is the most efficient um, strategy to use. You say that you have multiple models, so you can basically implement the different routing strategies. For example, the simple queries goes to the cheapest model, which is good for answering the straightforward queries. And then as the complexity grow, you define the different models onto that. Then output length control, you can use the bashing of the data, streaming you can involve, and there are multiple uh, strategies that could help you to reduce the overall cost of the product. So if you see that model routing itself, I have seen reducing almost 60% cost uh, of the product. Many people, many teams, we also had experience that cost is growing. So when we tried to do this model routing, that itself has given us the great cost reduction. So this is very effective strategies. Okay, so what goes into the observability of the AI system? So traditional monitoring watches your servers, but AI observability watches your model's mind. Right, there are four pillars. Pillar one, traces. Here you track the full request, everything from a request to LLM to the response flow, everything that your product code goes through, different flows goes through. You have to capture everything so that you have the end-to-end visibility of the particular call. What has been what was the input, what context you have retrieved, what tools have calls have been made, and how you arrive at the output. So everything you should be logging at. uh, Retrieval steps, latency per hop. You have multiple hops till you go to the output. So each hop has a latency involved. Each hop has a token observation involved. So you have to basically uh, everything log so that you know the exact where exactly is the problem in terms of the cost. Then prompt versioning also you should be tracing. Then second layer is the metrics. So you have a couple of key matrices that you should be monitoring for each AI products. For example, the token usage per session, cost per user or cost per task, model success rate, what is the hallucination frequency, escalation rates, um, etc. And then logs, full prompt plus response pairs, guardrails, trigger logs, user feedback signals, and error and the timeout logs. And you should be building the alerts, very important, because you don't want system to be failing silently and you never notice it. So you should be having the errors for the key aspects, like if there is a cost spike detection, or the latency degradation, or the output quality drift, or is there any policy violation happens. So everything has to be have the alert so that you catch the issue well before user notices it. So there are many tools in the market which you can use. Mm, as we know that tools keep on changing every week, but these are still relevant tools, mostly being adopted by many AI products. They are listed here, so you can use this. They are the most relevant tools. Without observability, you are just flying blind. Okay, you don't know your model is degrading until the users start noticing. So I have seen the examples of the recent AI products, and very recent example, yesterday only I got an email from one of the product that I'm using, and they have accepted that they said that's one of their feature which many users started complaining that they are not getting certain morning updates uh, about their portfolios, what product should be providing, and they noticed it almost after 45 days. And now they're saying that uh, this was silently failing and they didn't have the observability in place, and they even agreed on that, they even accepted that. So this aspect is very important for any product. All right, so before we look at the agentic AI and future, any questions so far? Okay, so uh, we are witnessing an evaluation from single prompts to
I have a
autonomous.
question. I have a
Yeah, yeah,
question.
yeah.
Sorry.
Mhm.
Yeah. So, as you said that we cannot take GPT-4 and then think about the use case.
Yeah.
So, if I will think to create a agent, so
Hmm.
both the things like the use case also and what model I need to select. So, both of them I don't know which one I need to take and which use case should be feasible. Like it should be useful, right? You said somewhere like okay, if it can be done in a manual process, so you should not use AI for
No,
that
no,
one.
not use. No, I said we should not directly start first thinking about the model immediately. First, we need to have the clarity on what we are problem we are trying to solve. Okay, like use case, is your use case really trying to solve certain problems, really will align to your business objective, or you're sure about whether this use case might result into a revenue generations or the cost reductions or something. So basically, uh, instead of directly starting which model to use, right? So you have a lot of models for every use case, then you can choose which model will fit the best for your use case. But first, use case clarity is important. Once we have the use case clarity and problem understanding, then we move to the next thing, right? And there also we cannot directly go for the latest model, right? There also we can start with the very very basic thing, like first thing, why would I need any model? I can start with the prompt only. Let me try to see if my initial feasibility prototype can be done using just a prompt and providing some my information like to product documentation, and use the better prompt. Does that gives me a initial view of that, okay, this use case can be implemented. Then Then we build on top of that. Okay, so then we look at the different model comparisons in terms of many aspects, right? Which model has the accuracy rate, what more accuracy rate, what are their cost offerings, how each model is providing the cost, what is their context window per model, which model gives the better context, which model is good at reasoning, right? So different model has a different expertise, and everyone has a different cost also. So then that comparison comes as a second step. But we should not start, okay, I will directly consider the model first. That anyways will be have to be done as a next step when you already know that use case is relevant, and now we can go for the building the use case.
So if I know the use case, then how I can select the model? Suppose I am doing something for the finance domain, something like it will act as an agent who can suggest like which SIP to take, which mutual fund to consider. So those
Correct.
kind of
So
advice,
yeah.
suppose.
So here your most important, you have to aspect three things, right? Generally, any product has three things. One is the accuracy. Second is your cost, and third is your latency, right? Some products require very very fast responses, real time responses. Some people, your key aspect is like the cost. I don't want the minimal cost, and some is the accuracy, most important. In the finance, the accuracy is most important, right? You cannot agree, you cannot compromise on the hallucinations, right? So data has to be very very accurate, and has to be, have the real time knowledge into it, right? So in that case, we can compare how's the chat gpt versus claude versus like who provides the best accuracy. So if you look at the trend and look at the user adoptions, the claude provides the maximum ethical accuracy in terms of, like, you see, right, many people, when it comes to the compliance and when it comes to the implementing something, they prefer the cloud, because the cloud, their principle itself start with the compliance and security. So then we do this analysis, market analysis of different models, look at their adoptions and which fits better into your use case, right? And then you choose, okay, this might be a better option for me. For some product they say, oh no no, for me the cost is most important, so I would go for the cheapest, the model which give me the cheapest cost. And some chooses, okay, which model gives me the most reliable real time data, like for example web search and all. Perplexity gives me the best real time web search, right, with citations and everything. So for research purpose they choose that. So this comes as a second step based on what is the key metrics that you are tracking for your product.
Thank you. It makes sense to me.
Yeah. Okay, so now we are witnessing an evolution from single prompts to the autonomous multi-step tools using the AI systems, right? The progression, earlier we had a prompt, and then it's a single turn interaction. Basically, you give some prompt, you get the response. Then you have the chain, where multi-steps deterministic sequence. Like you have the multi-steps, but it's a very, you know that the flow is deterministic. And then we started with agents, so something which can act basically. So act in the sense they can make a use of tools, and they can use a make of memory, and they can reason over it, they can plan, and they can execute on themselves. uh, but that is a single agent performing a particular specific task. And now we are into the space where we have the multi-agentic system, because each products have the different domains and different elements that needs to be uh, worked at, and one agent doing everything is not feasible. So that will also result into the model degradations, because as the scope grows for any model, the degradations and the accuracy, low accuracy, will start seeing. So the agent having the very specific, very expertise domain scope, they work efficiently. So in that case, we come into the multi-agent system, where we have one orchestrator agent or the main agent, and then he distribute based on the intent of the user, and which agent can solve it best. So for me myself is building the financial system for my own, where I am building the one stop solution for in entire family wealth management, and providing the various aspects of each asset class basically. So I have the multi agent system where there is a very expert agent across each asset. Like for mutual fund agent is there for mutual fund aspects, equity agent is there, the real estate agent that has a real domain knowledge of real estate. Then we have market specific agents, FD specific, it's a saving specific agent. So we have implemented the multiple agentic system, and but every asset class analysis and the questions are managed by the very specific agent, where the main agent manages the orchestration and the collaboration across them. So key capabilities of agentic system is basically planning, decomposing the task into sub goals, and reasoning over the steps. They use tools like they have to use multiple database searches. They have to use APIs to call certain even the external tools, code executions. They can do using the tools. Memory is most aspect, like they, if you have to provide the personalized responses to your user, right? So you have to maintain the conversational history, the ongoing history, short term memory, long term memory. And so because that helps agent to respond to a user in a very specific manner. If you might have observed, right, if you are using any LLM, chat gpt or anything, right, when you now ask something to chat gpt, after let's say you have interacted with it for maybe 10-15 chats, right, when you start new chat and ask something to it forms the response based on your persona. It builds your persona over the time based on your conversations with him, and then it responses you, and it gives you the examples very focused. Like you will see that okay, you had asked something similar earlier, so it gives the includes that history into your response and provides the response in that direction. So that's where the memory is used. And then obviously feedback loops, self critique, error correction, replanning, human in the loop for checkpoints for high stake decisions, and the guardrails. So these are the patterns I am building with. I am also, as I told, I am also building my own um, multiple products, just to keep into the using these tools practically, understanding their complexity, understanding their architecture. So it's very important you for anyone, right? So nowadays uh, we see the information flowing all across, but until unless you try doing something, you don't really understand how things work. So better do a hands-on on some of the use cases that will give you the real visibility into how things works, how cost comes into picture, how evals comes into picture, and that will give you the better um, decision making thinking actually. Okay, so let me leave you with the 5 principles to guide your AI product journey. The first is define success with evals before you write a single line of code, right? To build observability from the day one and not the afterthought. And this most important aspect. Start with the smallest valuable thing, then scale intelligently. And then make AI adoption a human story, not the technology story. 5, iterate relentlessly. Okay, the feedback loop is your competitive mode. The future doesn't belong to those who use AI, it belongs to those who build with purpose. Okay, and some of the quotes for thoughts you can read yourself, that would also provide some thoughts in your mind. uh, this is what I had, but there are each of this topic we can go lot deeper. So each of these aspects like evals, cost, observability, model selections, and the rack system, how rack systems are built, each of these can be a one session topic each, and we can go as deeper into those topics. But you can, I keep on sharing the guides. Like I have shared the cost framework guides, evaluation guide, observability guide on my LinkedIn posts. So you can have a look at the previous post I have shared. There I had given the entire guide that you can use to while building your products. Complete checklist of what all things you should be taking care when you implement in the product. And that's how what I had. But if we have a time, I can quickly show basically how observability dash real product dashboard should look like, and what you should build, and how that helps you finding the problems into the products. I mean, it's all depends on what time we have, and the if audience is willing to have a look at that. Okay, so one second, let me just start sharing something. Mhm. You see this? Can you see my screen which says AI operation centers? Okay, so was I was referring, right, one of the product that I am building. It's a finance management product, right? It's a multi-agent system products. So even though I started developing it, I started first building the observability and eval framework for that, because that will give you the key visibility and insights into how your product is behaving, and then you can improve on top of that. So this is how the eval product should be there from the day one, or as early as possible, basically before you go into the launch. So you see here it gives me the what is my today's cost, whether the caches that I have implemented hit what is the hit rate, overall average latency, was there any PII incidents during the testing. So right, this is during our testing only we are trying to put in a lot of PIIs just to test that whether we are tracking or not. So he had already captured one of the PIIs that was leaked. Uh, we have the alerts, right? It says the PII incident in last 30 days. There was one PII incident. The latency has spiked into some of the agents, right? So these are different agents. You see the market agent, support agent, family portfolio agent, equities agent, um, member portfolio agent, gold agent. So that gives the alert. Then you go down, so you have this entire cost framework observability implemented, right? So you have to measure every cost, so it should give you the cost per hour for a day, the overall cost uh, by a model, like how much is the cost by Haiku, how much is cost by Sonnet, and across different agents. Like we have this all these different type of agents, each of them how many calls were made, what was the input token, what was the output token, overall cost per call used by those agents, converted into the INR, and the total cost by agent. um, so you have the clear visibility, which agent is doing what, which agent is consuming maximum tokens, what is turning into the highest cost. So you can basically look at the very specific area that needs to be improved, right? Then you have quality evaluations, like what are the latency per agents, how much is the cache hits per agent. The PII is clearly we have shown that okay, there was a PII by support agent which had leaked email ID of a particular input. So and action it has taken was not deliver that as an output. It has sanitized it well before responding to the user. So it was good that it never reached to the user output, but we still tracked that there was an incident PII leakage, and even we added more uh, guardrail to avoid that. uh, any negative feedbacks from the conversations that we track. Then performance, like what is the p50 per latency, p95, p99 probably, uh, by models, latency per models, right? What is the latency for each model, different model. Token budget, we have like, you can define the token budget for each call. I have maximum this much token budget, so you should not cross that. So it is hitting the all, you see that many requests are hitting the 100% of that. So basically all the rates you see, right? So these are the observability where we know that okay, this rate have to be addressed, because that is something is not aligned with what we want. The semantic cache, how it is being used, how much is the hit rate per model. And then of course the what I was telling, right, the most, yeah, efficient cost control that you can implement is the model routing. So we have with simple queries we use Haiku, because it's the cheapest. Then the analysis queries we go into a higher model, Sonnet. And then for the most complex queries you use the latest model, uh, Opus. And here you can even have various models that you can define based on your then analysis of various cost providers by the LLM. So you are not restricting with one model. You can choose your routing based on uh, what matters most to you, right? And then the overall cost spent per agent, and total cost breakdown. So every call should be breakdown with what was the input token, what was the output token, in between was there any additional cost involved. uh, Tool call frequency, how much tool calls were made, what is the success rate of all the tool calls, whether every all tool calls were correctly made. Was there any drift uh, into the performance, 7-day quality drift, was there any degradation to the that also is captured. uh, you see the all these PIIs that we have defined, like okay, any of these should not be leaked into the output. You can define the custom PIIs additionally, whatever matters to us or for that product. And every query that you make, every query that goes, have are captured with all the essential information. So what this gives is, you are not keep on building the products for a long time, and then when you come to launch decision, and then you are realizing a lot of problems in the products, right? When you build it at the very beginning, so you already know whether your product is ready for launch or not. Is there anything that needs attention? So even offline testing, right, but your MVP implementation itself gives you the lot of insights and visibility into your product. Without this, it will become very difficult for you to understand what went wrong, why is the latency increasing, why is my cost this much, because we don't know where exactly cost is going. So each hop, every element, every uh, tools calls that we make, everything should be tracked. Every as many metrics we add is better for visibility. That tells us quickly, we can know okay, something is wrong, we need to fix it. So this will help in building in a stages and building in a right direction, rather than finding something wrong way at the very late stage. So most important aspect, build it yourself. So you can use ready-made evals and the observability frameworks that many tools provides. But for me, because I want to do more on the practical on each of the AI things, I implement myself everything. So no need to use any external tools, you can build yourself. Okay, this was something that I wanted to show. Um, so currently, the 2 3 products on my personal side I'm building, and this is how they look using the observability framework. So this product will come in soon, but okay, that's a separate aspect. All right. Any questions, guys? Okay, looks like we are good. Um, Let me know. I will also include some additional slides that gives more detailed on the cost frameworks and the um, evals frameworks. But on LinkedIn also you can check. Um, I had already shared some of the guides, PDFs, which are very very useful. You can check on those.
Okay, thank you, sir, for the insightful and engaging session. Your perspectives on AI, product innovation, and real world applications were truly valuable and inspiring. We sincerely appreciate you taking the time to share your knowledge and experiences with us. It was a great learning opportunity for everyone. Thank you once again.
Thank you everyone for joining and listening for a longer session. Thank you.
Thank you.
Thank you, sir.